Now, how do we find the determinant of a square matrix? Now, if A is a square matrix of order n that is greater or equal to 2, then the determinant of A is the sum of the entries in the first row of A multiplied by the respective cofactors. That is, you have the determinant of A is equal to the summation of the products A sub 1 times J, and the cofactor, okay, we have the Aij multiplied to its cofactor C1J, beginning from J equals 1 up to N. So we will have your A11, C11 plus A12, C12 plus dot, dot, dot plus A sub 1N multiplied to the cofactor C sub 1N. Okay, according to Theorem 3.1, which is about the expansion of cofactors, let A be a square matrix of order n, then the determinant of A can be evaluated using an ith-row expansion as follows. You will have the determinant of A is equivalent to the sum of Aij and its cofactor Cij, beginning from J equals 1 up to N. So we will have your A sub I1, C sub I1 plus A sub I2, C sub I2, and so on and so forth until you have your A sub 1N, C sub IN. Okay, this is using an ith-row expansion. So let's say at we're doing it, let's say at row I. Okay, we can also perform a j column expansion. So again, the determinant of A can be evaluated using the j column expansion, perform as you have here the summation of the product of Aij and its cofactor Ij beginning from I equals 1 up to N. So for example, we will have your A1J, C1J plus A2J times C2J plus and so on and so forth plus A sub Nj, C sub Nj. We are doing the expansion at J column. Now let us try of a 4 by 4 matrix. So notice that 3 of the entries in the third column are zeros. So to eliminate some of the work in the expansion, we are going to use the third column. So we will have the determinant of A is equivalent to 3. That is the Aij, right? We have the Aij multiplied by the Cij along a column. So we will have 3 times the cofactor 13. And then we also have plus 0 multiplied by the cofactor 23 plus 0 times the cofactor 33 and then plus another 0 multiplied to the cofactor 43. Now, since these are 0, then we only have to deal with 3 multiplied by cofactor 13. Now, we know that cofactor 13 is just equivalent to 1 plus 3, so that will be positive, is equivalent to positive multiplied by the minor of 13. So we only need to find the minor of 13. Okay, so using that one, we have 1 plus 3. So I've mentioned that using the checkered board sign, so that's simply positive. And this is the submatrix that results when we delete the first row and the third column. So say here we will have C13. So we eliminate the first row and then the third column. And we're left with the submatrix that contains negative 1, 1, 2, 0, 2, 3, 3, 4, and negative 2. Okay, then we evaluate again the determinant of this minor. So remember that this is the minor 13 and cofactor 13 is simply positive M13. So to find the minor 13, we need to find the determinant of this matrix. So again, we are going to, so this is already the cofactor 13, which is positive. And then we solve for the minor 13. Now to solve for minor 13, what do? We can use a cofactor expansion at column 1 since we have a 0 there. Okay, so again, evaluating the determinant of this, say using again a cofactor expansion at column 1 where we have 0 there. So we begin by multiplying -1 by its minor. Okay, so -1, since we will have a checkerboard sign positive here, so we only need to multiply this by the minor, and the minor is 2, is the determinant of the submatrix that results in deleting the first row and the first column. So you have 2, 3, and then 4, -2. And then we also have, so the checkered board is plus, and then minus, and then plus. So we have -0 multiplied by the minor of 0. Never mind, but let us just show it here. Deleting the second row and the first column. So we will have the submatrix 1, 2, 4, and -2. And then plus, that will be +3 multiplied by the minor of 3. So you have 1, 3. So you have the submatrix 1, 2, and then 2 and 3. So the determinant is equivalent now to, so you have -1, and the determinant of this is -4 minus 12 is -16. And then this is just 0. And then we will have +3, and then multiply to the determinant, which is 3 minus 4 is -1. So we will have 16 minus 3 is 13. Okay, so therefore, we can now find the determinant of the original matrix. Again, we multiply it by 3. So 3 times cofactor of 13, and cofactor of 13 is 13. So 3 times 13, that will be equivalent to 39. So here we will have 39. Now what about triangular matrices? A square matrix is upper triangular when it has all 0 entries below its main diagonal, and lower triangular when it has all 0 entries above its main diagonal, as shown in the diagram at the left. Okay, where do we see the diagram? Okay, we will have it later. So a matrix that is both upper and lower triangular is a diagonal matrix. That is, a diagonal matrix is one in which all entries above and below the main diagonal are 0. Okay, according to Theorem 3.2, the determinant of a triangular matrix is simply, okay, if A is a triangular matrix of order n, then its determinant is the product of the entries on the main diagonal. That is, we will have the determinant of A is A11 times A22 times A33 times A sub nn. Okay, for example, this is a triangular matrix. So according to the theorem, the determinant is simply the product of the diagonal entries being 2 times -2 times 1 times 3, which is equivalent to -12. Okay, so we were able to define the determinant of a matrix, and we use a cofactor expansion. We can use a cofactor expansion along a row or along a column to evaluate the determinant. And we also see here that the determinant of a triangular matrix is simply the product of all the diagonal entries. Okay, so that's all for the lesson for today.